So this is the repeated zero-sum game where we are given left, right, top and bottom, and the first value in these brackets is the player one's playoff values, and the second value is player two's playoff values. So first we have to find pure strategy Nash equilibrium. In repeated zero sum in the repeated zero sum, what basically happens is that the game goes on for multiple rounds, and we have to find the given sub questions. The first sub question is that find the pure strategy Nash equilibrium, and the second sub question is that we have to construct a pure strategy subgame perfect equilibrium in which B comma R is played in the first stage. So uh, coming to the first sub question, where we have to find the pure strategy Nash equilibrium. When does a pure strategy Nash equilibrium occur? It is when both the players, player 1 and player 2 in our case, will select a strategy where neither of them can improve their payoff by deviating. So player 1 will select a playoff, player 2 will select a playoff, and both of them, after choosing their particular payoffs, they will analyze if there are any other better payoffs, and from their analysis they come to the conclusion that there is no better payoff than the one that they have currently. So what are we going to do? First we will check player one's best response based on player two's choice. So on the basis of player one's best response, it is determined by player two's choice. So what can player 2 choose? Player 2 always means going in a horizontal direction. So player 2 has two moves over here, left and right, because player 2 always goes in the horizontal direction. So player 2 chooses L. Player 2 can choose L. So according to that, what will player 1 become? When player 2 chooses L, when player 2 chooses L, player 1 can become 2, or player 1 can become 3. These are the two possible values that player 1 can have. So basically over here we have player 1 2, player 1 3, under the condition that player 2 chooses L. So basically over here when we compare, 3 is greater than 2. So where do we have 3? We have 3 in the when in the bottom playoff. So basically in this scenario, B is the best option for player 1. Now player 2 has the other option, which is R. Now when player 2 chooses R, player 1 has two options again. It can either have the value of 1, or either have the value of 0, or either have the value of 1. So when we compare these, 0 and 1, 1 is again greater than 0. So basically B is again the best case scenario for player 1. So irrespective of whatever P2 chooses, whether P2 chooses L or P2 chooses R, the best option for P1 is to choose B. Now when player 1 is done, we will go and analyze the best response for player 2. Now this will be dependent on the choice of P1, player 1. So player 1 can choose T or B. Player 1 always goes vertical, player 2 always goes horizontal. So basically player uh, player 1 will choose T first. So according to that, player 2 can have 2 or 3. Player uh, player 2 can have 2. Player 2 can have 2, or player 2 can have 3. So uh, when we put those values here, 3 is greater than 2. So what is better? R. The scenario of R is better. Then player 1 chooses B. Player 1 chooses T, and player 1 chooses B. Over here we are doing player 1 chooses B. So in that case, what can P2 be? In that case, uh, it can be either 0 or 1. It can be either 0 or 1. So basically when we compare, we get R to be the better scenario for player 2, irrespective of whatever actions P1 chooses. So P1 can choose T, or P1 can choose B. The better option for player P2 is to choose R. Next, now both have chosen their best case scenarios. Both have chosen their best case scenarios. For player 1, it is B, and for player 2, it is R. Now, keeping these best case scenarios in mind, we have to choose a Nash equilibrium. So basically, it requires both players' best responses. Now, what are best case responses? B and R. So when we take B and R and we look in the table, B and R gives 1 comma 1. So the Nash equilibrium we have is 1 comma 1. So we check what deviations does it have, like where can P1 go? Can P1 go somewhere else such that it might have a better value? So P1 chose B, P1 chose B, so where else can it go? It can go to T. So when it goes to T, when you check in the table, you will see that it decreases to 0. Is that beneficial? No, it is not beneficial. So it will stay where it is. Same for P2. P2 deviates from R to L. Same, it decreases from 1 to 0. Is it beneficial? No, it is not beneficial. So basically, the most beneficial thing being that they both stick to B comma R. Now in this question, it is specified that the game is played twice. That means it has 2 rounds. Now we have to find we have to find the pure strategy subgame perfect equilibrium in which BR is played in the first stage. So BR is played in the first stage. We have fulfilled that want. Next, what do we do? Uh, we will start from stage 2 and then go to stage 1. We will start analyzing from stage 2 to ensure that we choose values for stage 2 such that it goes to stage 1 being B comma R. So how do we do this? We do it by backward induction to construct SPE. SPE is basically subgame perfect equilibrium. What do we do first? This is basically all theory and some logic. So what does it entail? First we analyze the second stage. Now second stage, according to the question, it is the last stage. The second stage is the last stage, which means there is no future. They don't have to worry about what payoff might be next. So basically, players play a thing called stage game Nash equilibrium. Since from part A, the only stage Nash equilibrium was B comma R, so the same thing will be played in this round also. That is all that is to be written here. That there's no future payoffs, given that there are only 2 rounds in the game. There are no future payoffs. So basically, since it had the previous game had only the only stage Nash equilibrium was B comma R. So the next stage, that is stage 2, will also it will have a prescribed playoff of B comma R only. This was the first step of the second sub question. Now what is the second step? We are going to construct a strategy profile. Now a strategy profile uh, to achieve history independent strategy profile in the first stage. So basically it should be independent of history as in the previous stage. We will start from we will analyze this in case of player 1 and player 2. Now in player 1, player plays B, that is in stage 1, player plays B. Then player also plays B in stage 2. Irrespective of whatever the outcome is in stage 1, it does not matter. In stage 2, player has to play in stage 2 player has to play B only. Player 1 has to play B only. We have already reduced and calculated why as to what it will play in stage 1. But uh, it has to be written here that irrespective of whatever outcome, it will be playing B only. Same will be written for player 2. Player 2 in stage 1 played R, so irrespective of whatever it was done in stage 1, in the second stage also it will play R only. So basically the path that will be followed is B comma R in stage 1 and B comma R in stage 2 also. What are the payoffs in both these stages? 1 comma 1 and 1 comma 1. So total payoff is 2. 1 plus 1, 2. 1 plus 1, 2, where it is 2 for each player. Last step is to verify. Last step is to verify this subgame perfect subgame perfect equilibrium. So basically, this is also just theory where it is second sub second stage subgame has to be analyzed first. So basically, what is our continuation strategy? Where B comma R's Nash equilibrium is established in stage 1, right? No player can deviate from it to improve. That is basically the conclusion that we came to. That no matter where they go, B comma R comma 1, right? 1 comma 1 was what they reduced to. It was the best thing that they could do. So there's no way they can deviate to come up with something better. That is all that we are writing here. This was we are doing backward induction here. We are writing this in terms of backward induction. Second stage done. Now first stage with continuation in stage 2. So basically if P1 we are verifying here, right? This is just some theory that was written and then we are verifying here as to why, as to like approve for our findings. So basically P1 deviates to T in S1, right? So where can it deviate to? It can deviate to T. So basically S1's payoff is 0, S2's payoff is 1, considering the deviation from BR. See, BR stays constant, right? In stage 2 it is given कि BR ही रखो, in stage 2 BR ही रखो, ठीक है? But it can deviate. हम लोग deviation check कर रहे हैं तो कहाँ deviate हो सकता है? वो T को deviate हो सकता है, तो हम लोग B से T को check कर रहे हैं, तो B T R के लिए P1 को क्या मिलेगा? 0 मिलेगा. This is from the table again. Accordingly स्टेज 2 के पे ऑफ में हम लोग उसको कांस्टेंट ही रख रहे हैं तो 1 का 1 ही रहेगा. तो यहाँ पे टोटल क्या आ रहा है? 0 प्लस 1, 0 प्लस 1. इट इज लेसर कंपेयर टू द अदर टू द ओरिजिनल वन वेर वी गॉट 2, राइट? 1 प्लस 1 2 आ रहा था, वही वी कैलकुलेटेड अर्लियर. देखो 1 प्लस 1 2. सेम like this is the calculation. This is the original calculation. B comma R 1 comma 1, 1 plus 1 is 2. So basically the thing that we did here, we are going to do it here and we are going to show that we're going to stick to the original plan and we're not going to deviate anywhere. The same goes for player 2. Player 2 deviates to L. ठीक है, it's going to deviate. तो वैसे ही deviate करने पर जब वो R से L पे deviate होता है तो जब हम लोग उसको टेबल से उसके values derive करते हैं तो we get 0 plus 1 1 compare it to previous values. ऐसे ही ऐसे यहाँ पे किया था तो we get 2 over there also. So basically it is less beneficial to deviate. Okay, it is less profitable. So this is one conclusion wala sentence that is to be written. Pure strategy SPE. P1 plays B both stages and P2 plays R in both stages, ensuring that B comma R is played in S1. So basically we have ensured that B comma R was played in the stage that it was required. How? By this entire solution. So this was a repeated zero sum game.